First assignment. So if you're logged into to your Blackboard, if you go to course material, under there will be, these are videos from last semester. I will be posting the ones for summer also here, but you can close those. So I'm sorry, assignments are available here under assignments. And the first assignment is about data modeling, right? You'll you can open it up. There's a link, and there's the database assignments. So this first assignment asks you to create a UML class diagram. So we'll give you a problem statement, which those that are taking web dev will recognize. It asks you to go through the process of creating a data model, right? A UML data model. Now the domain of the problem statement is fairly familiar to you, right? If you're familiar with Blackboard, that is the domain. The domain is some learning management system, online learning management system. Yes. So there's faculty, there's students, there's courses, sections, assignments. Yes. So all this is a domain that is familiar to you. Okay. But certainly, I could have chosen a domain that you're not familiar with. Okay. I don't know, astrophysics. Any astrophysics here? Maybe not, I don't know. So some domain that, if I gave you a problem statement in that domain, yes, you couldn't tell what a noun is from a verb. Okay, you're not familiar with the terms, with the vocabulary. Okay, you don't know that certain nouns actually describe other nouns. Right, or that some nouns are actually made up of other nouns. Right, you don't know the relationships between any of them. Yes, okay. Somebody would have to explain it to you, or perhaps a problem statement. From the problem statement, you could maybe decipher that what the relationships are between the nouns. Yes, but here the problem statement that I'm giving you is fairly familiar. I'm describing use cases that you might find in Blackboard, right? So a faculty can create a course, they can create assignments, they can create add content to those assignments. To the course. They can maybe move them around. They can move the widgets around. They can create an exam, and then students can take those exams, right? They can answer multiple choice questions, fill in the blank questions. So you understand the domain, yes? So I'm not going to read it out loud, but basically it describes what faculties and students and a registrar's office, right, what they might do with using some kind of learning management system, right? Something like Blackboard, but not necessarily Blackboard. Okay. So given that problem statement, it asks you to do the following. So first of all, you will be asked to create a class diagram, right? And one of the first steps in creating a data model is to identify all the nouns and all the verbs, right? The nouns are going to give you a clue on what objects, what piece of data do we want to capture, right? So they'll be if they say a faculty, a student, ooh, that's a noun. Maybe I want to capture information about a faculty, about a course, about a section. So all those nouns are clues of things we want to capture information about, that we want to store information about. Yes. And the verbs will give you clues on what the relationships are between the nouns, right? So, for instance, if they say a faculty authors a course, right, or authors many courses, right? So that authors. Right, that kind of gives you a clue that there's a relationship between a faculty and a course, right? And that a student enrolls in a section, right? So that verb enrolls also gives you a clue that there's a relationship between those two nouns, right? In a naive way, when you don't know anything about the nouns, as far as you're concerned, every single noun is a class. Right, in the sense of like a Java class, yes, or UML class. But as you start reading through it, you start realizing that maybe not everything is a class. maybe some nouns are actually attributes of some bigger class. Yes? For instance, you might find, say you don't know what a username is or a password is, right? Obviously you do. But say it's a term in another domain that you don't know, right? As far as you're concerned, a student and a username and a password, right, are all just nouns, right? And they're all legitimate candidates for a class, right? But as you read the description, you realize that, oh no, wait a minute, no, username and password are used to describe a student, right, or a user. And then you realize that these are not classes themselves, they are attributes of some other class, yes? Right? But the first step is to just do an exhaustive list of all the nouns and all the verbs, right? And a lot of the nouns will be redundant, are irrelevant, right? They're not providing any new information, right? Maybe some nouns are ambiguous, right? Or they might be describing the same thing, where sometimes you call it one way and sometimes you call it some other way, okay? But they're actually referring to the same thing, right? So you need to create some kind of data dictionary, right, where we agree, right, that it's the agreed way that we're going to call this thing, okay? We're gonna. So that's the first step, right? You're going to list an exhaustive list of nouns and attributes and verbs. The next thing is that you'll try to identify which nouns are special cases of other nouns. Right? So, for instance, I might say you might find a noun such as student. Somewhere else will say undergraduate. Somewhere else will say graduate student. Okay. Well, it looks like undergrad and graduate are kind of like special kinds of a student. Yes. So they might have features that are similar to each other, right? Or they're common amongst all students. But graduate might have special attributes that an undergrad does not, or vice versa. Okay. So this asks you to identify those cases where which nouns are special cases of other nouns. Okay. And you would capture that as generalization or specialization. As you are going through this, you need to document your train of thought, right? Sometimes a generalization, an alternative way is to capture it as an enumerated data type, okay? So for instance, if I say a semester, the concept of a semester, but then I say, well, there's a spring semester, there's a summer semester, there's a fall semester. That's kind of like an iffy case, right? Is that a spring semester and summer semester just a special case of a semester, right? You could. That's a legitimate way of thinking about it, right? That those are just special cases of a semester. But another way of capturing is that it's just a enumerated data type, right? It's just that it's these semesters are just special token values for a variable semester, right? So you could argue both ways, right? Do I capture as a generalization or do I capture as a enumerated data type? Yes. So for your choices, you're free to choose, okay, which way you want to go, but you need to make a compelling argument why you went one way or another way. Okay. I'll have a preference, and if you have a compelling argument why you didn't do it the way I wanted to do it, or what the rubric says, we'll give you the points anyway. Okay, we'll take your argument. All right. Then we'll ask you to identify associations between the various classes. Okay, and there are various types of associations. Whether if the life cycle of one of the classes depends on the life cycle of another class, right? We say that that's a composition, right? One is made up of the others, right? The others can't exist with the one without the one. Okay. For instance, if you have a course and you have multiple sections for one course, but then somehow that course gets canceled, there's no point of having the sections, right? So the lifespan of sections depends on the lifespan of the course, right? The course goes, all the sections go, right? It makes no point of having sections without the course, okay? But say a faculty can teach many courses, right? So there's also looks like there's a one-to-many relationship between a faculty and the course, right? But if the faculty gets fired, the courses don't get disappear, right? We can just assign another faculty, yes? So that we refer to as kind of like an aggregation. That's a reference between a one-to-many reference between a one and many, yes? But the lifespan of one does not depend on the lifespan of the other, yes? So we ask you to capture those kind of relationships, right? As aggregations or associations or compositions, right? As you, we'll ask you to identify your train of thought at giving us a very naive version of your class diagram, right? I don't want to see just the results of the class diagram, okay? I want to see what did you think first, right? Give me a first approximation of what the class diagram might look like, right? This is what I'm referring to as like a naive class diagram. The most naive class diagram might be all nouns are classes. Okay, that's the most naive type of class diagram. And as you progress and read more and you identify these relationships, you might identify that, well, actually these classes are better attributes describing other classes, right? So they're no longer classes, they're attributes. Yes? So I want to see your train of thought of why you chose certain attributes instead of being classes. For instance, there might be attributes that are kind of arguable, right? That there should be attributes or classes. Say an address. Should an address just be a string that is just an attribute of another class, right? Where it's just a variable, right? That just contains a string value of the address. Or should it be a separate class where you have just many records for all different addresses with a normalized schema that has street and city and state and whatnot, right? So you could argue both ways, right? Should it be an attribute or should it be a class? So I want to see your train of thought. Now there's some constraints in the problem statement that forces you only to come to one particular conclusion, right? That addresses cannot be an attribute; they have to be a class. Okay, but I would like to see you, go through that process of saying, oh, it's an attribute. So, no, it should be a class. Okay, so that's this part here. Nuclear energy. Oh, okay. Yeah, so the vocabulary. So you would come up with maybe a naive class diagram. Some nouns might be redundant. Some nouns would be irrelevant. Okay. Some nouns would be ambiguous, and they're designed in there. They're deliberately ambiguous, right? They're deliberately irrelevant. Some nouns are there just to trip you up. Okay. All right. Some correct data types. I guess you could all, just some data types that are obviously dates or are obviously numbers. Okay. But other than that, a string can hold anything. But make an effort to try to use the appropriate data types for the data that you're collecting, whether it's a date, an integer, a float, a varchar, or I'm sorry, a string. Cardinality, you need to capture in relationships. You need to capture, how many are participating in every single relationship, right? If you have a one-to-many, a many-to-many, a one-to-one. Some of the associations up here, some of the associations have cardinality implied, right? Like for instance, an aggregation or composition implies a one-to-many, right? So typically you would not also add cardinality there, right? But to make it easier, on the TAs for grading you, please include cardinality on all associations, even if it's implied. Okay, so I need you to explicitly tell me what the cardinality is. All right? Also, remove any inadequate redundancy or redundant cycles. For instance, if you have classes that fall in a cycle, right, where you can navigate from one class to another from any number of cycles, that's a clue that there might be some redundancy there that you might need to remove it. Sometimes those cycles are needed, right, because there might be some queries that some queries that that need that cycle. All right, so not all cycles are redundant. But one of the final reify. Reification means you might capture a conceptual data model that can't actually be implemented in SQL, right? For instance, association classes, right? Those are typically there's no way to capture that, or inheritance. There's no way to capture that in relational databases, right? So this step asks you to reify, meaning convert the conceptual model into a more concrete representation that can actually be implemented in SQL. Okay, and we'll explore that in class. And finally, 5 points on using proper English. Okay, right. So one of the more important parts of our career is to be able to communicate ourselves. Okay. All right. The problem statement. You just read up on that. Okay. Any questions? All right.
Yeah, actually, sorry.
Yes.
When is this due?
2 weeks from now.
Okay, got it.
So not this Sunday. Following Sunday? Is that what it is? Is that what the agenda says?
Because I don't think it's Wednesday, May 23rd.
Okay.
So I wasn't sure if that was the due date.
Okay, no, it'll be always due that Sunday.
Okay.
Sunday?
Yeah, Sunday at midnight. Okay. All right, I'll change the dates so that they're clear that they're on a Sunday.